Hey. So let's start this chapter 10. Let's start this second module. Let's get this going. So I have provided you with some notes for section 10.1, 10.2, and 10.3 and 10.4. So you can see those notes right here. So right now in 10.1, we're only going to focus in on this piece right here. So these are some information that's going to help you. So these are those Pythagorean identities that we've kind of talked about a little bit in chapter 9, but now we're really going to hit these things up. And then right here, we've got how negative angles are affected when it comes to answering questions. So like if you're doing sine of a negative angle, you can just move the negative sign out front. If you're doing cosine of a negative angle, you can drop the negative all the way around. Okay. And then, so here are the signs of all them. So you can see that cosine, it's reciprocal. The negative angle actually you can just worry about the positive angle. And then when it comes to sine and its reciprocal and tangent and its reciprocal, the negative angle makes the negative kind of pop out front. Okay. And then down here, it's also important to know that all of these Pythagorean identities, you can rearrange them and solve for different pieces, like sine squared is equal to 1 minus cosine squared, or cosine squared is equal to 1 minus sine squared. So even these can be rearranged and get other Pythagorean identities. So that's super important for us. Okay, so in these notes that I provided for you, you can see the notes for section 10.1, 10.2, and then you scroll to the next page, 10.3, and 10.4. So as we progress through each section, you'll want these notes. And know that when we get to section 10.2, even the notes from before are still important for us. So even though I'm going to add on new pieces of information in 10.2, all these 10.1 notes are still important. Okay? Also, besides that, I should have put these on those notes, but I didn't. So in our slide that you see right here, these are other trig identities that we know about. And again, we've already talked about these, how cosecant is the reciprocal of sine, how secant is the reciprocal of cosine. Okay, so you can see the reciprocal idea here. Tangent or cotangent is the reciprocal of tangent. And down here, these are some other ways that we can talk about tangent and cotangent. Because remember back in the unit circle when we talked about how sine was equal to y and cosine was equal to x. And remember that we said tangent is equal to y over x. Well, hey, look at this. If I take the y and replace it with sine, I got sine on top. If I take the x and replace it with cosine, you get the cosine on the bottom. Look, right there, sine over cosine. And then again, we already know that cotangent is the reciprocal of tangent, so you just flip it. So cosine over sine is also another way that you can find cotangent. So we're kind of taking those ideas that we talked about all the way back in chapter 9, and we're just now using them. So again, we knew that cosecant theta is equal to 1 over y. And as we talked about before, we already know that y is the same thing as sine. So cosecant is 1 over sine, which again is just showing you that it's the reciprocal. Okay, so we got all these identities. And don't forget that you can also do this too. This is A-okay for us. Well, if cosecant theta is 1 over sine theta, then sine theta is also 1 over cosecant theta. Secant theta is 1 over cosine theta. So if I talk about cosine theta, we know that it is 1 over secant theta. So we can talk about those as well. And then you can do the same thing for cotangent and tangent here. We could say that tangent theta is equal to 1 over cotangent theta. So there's lots of cool things you can do with identities once you know them. And that's really what chapter 10 is all about. We're going to talk about some properties, some identities, and we're going to use those to our advantage and do a lot of, like substituting in and replacing. Like what you saw right here. We knew that sine and the y value are the same. So over here, I just replaced the y value with sine. And I replaced the x value, which is the same as cosine. And that's how we get this trig identity, sine over cosine. Okay? So, a big thing in chapter 10, and we're going to get a lot of practice in this in 10.1, is the real reason why I like trig a lot. This is where trig kind of hooked me. Because what we're getting into is we want to verify identities and verify properties. Okay? So what you're going to see, kind of give you a preview, you're going to have one side of a trig function equal to another. And this is a true identity. This side really does equal this side. And we want to verify that. It's kind of like proofs that you did in geometry, but these are all algebraic. Okay? And all we're going to do is substitute in pieces of information that we know, okay, to make one side look like the other. And so what I call this, it's kind of like a game, okay, where the game of it, I'm going to give you the rules here in a second, and you use those rules to make this side match that side. Okay, it's like a puzzle in a game. This is what made me love trig a lot, where I got to, a lot of different substitutions, and you can create a lot of cool identities and things like that. And I can show you that, yes, this identity really is this. It's really true. Okay? So these are the rules to the game. Okay? I can only give you tips. This is the other hard part to this. Well, not really the hard part, but the part that you got to get used to is that I've got 6 tips here. These are things that you can try, okay? I don't have any hard, fast rules that can help you. I don't have anything that says you must do this first, then you must do this, then you must do this. There's no step-by-step process for this. This is purely, here are the rules to the game. Use them at your will or your discretion to make this happen in the end, okay? So this is the setup. So kind of give you an example. Again, kind of going back to that example that I showed you. This is the setup. This is the winning condition. And up here, this is how you play the game. Okay? So some ways that will help us verify identities is we can use fundamental trig identities. That's what you see on the handout. Those are fundamental trig identities, okay? So all of this stuff that you see right here, we can use those and do substituting and replacing, okay? Also, the same thing that I showed you right here on the first page. These are all trig identities. These are reciprocal properties, basically, okay? Reciprocal identities here. So we can use those. So that's what I mean by, in here in tip number 1. Use identities, replace things. Tip number 2, very, very a kind of important tip. Start with the most complicated side. Because it's easy to take something complicated and simplify things down to get to the side where it is very, very small. It's hard to take a small side and build it back out to something complicated. It is very, very hard to do that. So again, in that example that I keep jumping back and forth between, don't start with this side because it's tougher to take this side back to that one. Start with the more complicated side here and take it to this guy. Okay? Just like another example right here. This is like the last example. Start with this more complicated fraction side and get to this one. Okay? It's easier to deal with this than it is to take it backwards from the simplified side. Okay? So general rule of thumb, usually the more complicated side is on the left-hand side. So start on the left-hand side, make it look like the right-hand side. Other idea, turn everything into sines and cosines. Get rid of tangents, get rid of cotangents, get rid of secants and cosecants, turn them into nothing but sines and cosines. Sometimes that helps a lot. Sometimes it doesn't. Okay, sometimes there's faster ways. Know that you can factor trig expressions. So factoring can help us out. As you're working through, keep in mind the side that you are not manipulating. Remember, the side that you're not touching, that's the goal. That's where we want to get to. Hence why we start with the complicated side. Okay? We want to take the complicated and reduce it down to a simplified side. So remember, your goal on this is the side that you're not touching. Keep that in mind. Okay? If the side that you're not touching is all in sines or cosines, then take the complicated side and I would turn everybody into sines and cosines since that's what I want in the end. Does that make sense? Okay? So again, when I'm looking at this example, not that one, but this one. See, I have sines and cosines here. In the end, over here, I want tangents and cotangents. Okay? Maybe it would help if I turn these into sines and cosines and compare the two sides. Sometimes you can work both sides at the same time, and there's nothing wrong with that too. I just don't talk about it as much. But in the end, think about your final goal. I need something to get me to tangent and cotangent. Okay? Some way, some shape, some form. So always keep your end goal in mind as you're working through. And last but not least, another way that you can do it, always remember this, you can multiply the numerator and denominator by what I call quote unquote 1. Okay? You can always multiply by 1. And by 1, now this 1 can look at so many different ways. Multiplying by 1 can just be that. Multiply the top by 1 and the bottom by 1, because 1 over 1 is 1. Or I could have to multiply by 2. Multiply the top by 2 and the bottom by 2, because 2 over 2 is 1. You see what I mean by when I say multiply by 1? Whatever I have to multiply the denominator or numerator by, I multiply the same thing in the denominator because that's multiplying by 1. So maybe I have to introduce the function sine. So if I want to, force the function sine in, I would need to multiply a numerator and denominator by sine. Because multiplying by sine on the top and sine on the bottom, that's sine over sine, which is 1. You'll see this come to life when we do some examples. You'll see all of these come to life when we go through these examples, okay? But again, this is not a process. Do not start here, then go here, then go to 3, then go to 4. These are tips. Some of these work better than others. Some of these problems we're going to look at, you're going to find that there's more than one way to do them. Some of them only have one way to get through them. When you start identifying stuff, sometimes you will start down a road, like maybe you turn everything into sines and cosines and you find that it's a complete mess and you get stuck. So maybe you should go back and try something else. So sometimes when you're going through this, you're going to hit dead ends. That's okay. You just go back to the beginning and you rework it. You found one way that didn't work, but I promise you, you'll get to a way that will work. So sometimes you're going to run into a dead end, and that's A-okay. Just go back and rework it. There's nothing wrong with that. I've had to do that many a time. Okay? So, first things first. It says express as a trigonometric function of a positive number. What they means is they do not want the negative for the angle. They want you to tell us what's going to happen with this as a negative angle. Okay? They want you to express it as a positive number, which means, again, your answer, they want the trig function in it. So my answer is still going to have cosine. My answer is still going to have cosine. My answer is still going to have cosecant. But they want to know, what does the negative do? So go ahead, pause this video, and see what you think. Again, remember, I gave you a sheet that talks about negative number identities. Pause the video and give it a shot. Go. Okay, so all you're going to do for this guy, cosine of this negative angle. Remember, when you have a negative angle inside cosine, it just means it's the same as if we took the positive version of the angle. So what they're looking for an answer is cosine 4.47. That's it. That's what they want. This is a trigonometric function of a positive number. That's a positive angle. That's what they're looking for. That's it. Don't go to your calculator. Do not pass go. Do not collect $200. That's all they want. Okay? So if that makes more sense now, go ahead and try the other two. Pause the video. Okay. So what's going to happen here? Well, the answer is going to stay a negative cosine 4.47. Okay? Because we can't touch the outside, because all that happens is, you see what happens. I mean, all I did was just take this problem and put a negative in front of it. So cosine negative 4.47 is the same as cosine 4.47. So negative cosine negative 4.47, that will be the same answer as negative cosine 4.47. So the negative just goes away when you're dealing with cosine, because that's what our identity says. Cosine, as a negative, you just deal with the positive version. The negative out front stays. So on this one, this is the answer they're looking for. Negative cosecant of 3 pi over 5. That's what they want. Because again, you look at your notes, a negative angle. Oh, come on. There we go. So a negative angle just pops it outside and says, well, why don't you just deal with the negative cosecant of the positive angle? So that negative we had here popped out front, and we're going to deal with cosecant of that positive angle now. That's it. That's what they want. So whenever you have that negative angle in here, they want you using these negative number identities and writing out what the function is. Okay? See? Not too bad. And all we were doing, just like in we were kind of verifying, we are just using trigonometric identities. That's all we were doing. Okay? So let's look at the rest of this. So the rest of this is going to be all about like verifying and simplifying, putting this information, these tips to use. All right. So right here, the directions are simple. It says simplify. Okay? So how can we simplify this? Well, we already got it in terms of sine, so there's no point in going back here and turning everything into sines and cosines. So we already got sines. There's not two sides, so we don't have to worry about starting on the complicated side, so we don't have to worry about that. We don't have to worry about keeping the side we're not manipulating, because again, there's not two sides. It's just simplify whatever we have. So, factoring, if we go back to this guy, factoring, this can factor, but that's not what they want. They want you to simplify. Simplifying means usually what you're going to do is you're going to reduce this thing down to one item or maybe a number. So in this one, really what they want you to do is they want you to use identities using that tip number 1. Because in the identities, we know that sine squared plus cosine squared equals 1. And remember, in those, they say that we can take this guy that we had right here and we can manipulate it. Look at this. 1 minus sine squared. What is it equal to? Cosine squared. That's simplifying. They really wanted you to take this and replace it with cosine squared x. That's a simplified answer. That's what they're looking for. Okay? Because all they did was get the cosine squared piece by itself. Minus sine squared, minus sine squared. See? Cosine squared is equal to 1 minus sine squared. That's all they were using, was using that Pythagorean identity of sine squared plus cosine squared equal to 1. Okay? All right. So, sometimes when you're looking at these, they might change the directions where it says complete the fundamental identity for the function. So these directions could have easily said that because this was a fundamental identity. So the directions could say complete the fundamental identity for the function. They don't always just say simplify. Or the directions will say write as a constant, single trigonometric function, or a power of a trigonometric function. So this example right here where it says cosine squared x, that's an example of a power of a trigonometric function. Okay? But there are other ways that this could have come out to a single number answer. Like if I just had this written out. If I had sine squared theta plus cosine squared theta, and I said simplify, your final answer would have been 1. That's what they mean by a constant. Okay? And any trig function that doesn't have a power is what they call the single trig function. Okay? So, like, say your answer came out to be just sine theta. That's what we mean by a single trigonometric function. All right? So these are 3 ways the directions are going to come at you. They might say simplify. They might say complete the fundamental identity for the function. Or they might say write as a constant, single trigonometric function, or a power of a trigonometric function. Okay? So kind of giving you a brief glimpse of what this means by a constant, single trig function, or power of a trig function. Okay? Power of a trig function. Notice it says a trig function. That would be like 1. That's like this, cosine. Single trig function would just be like an answer of sine or tangent. And then a constant would be like 1 or 0. Those are generally the constants we tend to run into. Okay? All right, let's do another one. Try this one. Pause the video, give it a shot. They want you to simplify, okay? And really what they want in this one, some of these are multiple choice, some of them are fill in the blank, just so you know. This one is like a multiple choice question. So if you look at the multiple choice, sometimes that helps you on where you want to go. And in this one, in your homework, it's like a multiple choice question, and they are wanting you to get to a single trig function. Just to kind of give you a heads up on this. But pause the video, give it a shot. Simplify. All right, so this guy. There are a couple ways that you can approach this. There are lots of ways to get to this answer. Again, it's all going to be about what you can remember, okay, and what you want to do. So I'm going to show you 2 ways to get through this. And in this chapter 10, this is where you need to, your algebraic skills are going to be put to the test. You're going to do a lot of algebraic manipulation, okay? Like adding, subtracting fractions, multiplying and dividing fractions, things like that, okay? Rationalizing. So in this guy, one of the things you could do is we have that tip number 2 where it says change the sines and cosines. Okay, that's easy. So cotangent is cosine x over sine x. So right there, I exchanged cotangent for sines and cosines. And cotangent is made up of cosine over sine. Down at the bottom, we know that cosecant is 1 over sine. So I turned this into sines and cosines. Now, we have discussed this before. We don't divide fractions, but we multiply them by reciprocals. So keep the numerator fraction. Division becomes a multiplication. And flip the bottom fraction. What's going to happen to the signs? They're going to cancel out, leaving us with cosine x, or cosine x over 1, but they're just going to keep it as cosine x. And that's the multiple choice answer that they were looking for. Okay? Now that's one way to do it. Another way to do this, kind of thinking about what's going on. Do I really want to show that method? That's fine. I mean, it's more complicated, but I want to show you that there's lots of ways to do this. And this is a good technique to know anyway. Know that whenever you have fractions, you can always kind of separate them into two different ideas. Like you could think of this, like if I wanted to turn cotangent in terms of cosecant. Because if I have a cosecant up here, I can cancel it out with that guy, right? So we can think of cotangent as cosine x over sine x, but say I wanted to keep the cosecant. Again, there are lots of ways to do this. This is all about just manipulation, using identities that you know. Up here, I can separate this into two fractions. It really does look like this. Cosine x times 1 over sine x. That's how I can think about these. I can move the cosine in front and call this 1 over sine x. And then on the bottom, I still have cosecant x, right? And then now I know that 1 over sine is cosecant. And on the bottom, I have cosecant. Well, what's going to happen between my two cosecants? Just like before, cancel out. What's left? Cosine x. So again, I gave you two ways to get through this. All I was using, like in the first one, I used trigonometric identities. Or actually, no, sorry. In the first one, all I did was turn everything into sines and cosines. In the second one, the black way that I went through this, so in the blue, this is all sines and cosine work. In the blue, I did a little bit of sine and cosine work, and I used identities in the end to help me out. So, see, as I was saying in the tips, there are lots of ways. These are not in order, like do this first, then do this. Then these are just, suggestions on how you can get through it. And that's why, this is why I like trig a lot, because like I said, this is kind of like a game. Okay. I know the rules of my games now. Those are those tips that I have. And now I can use them any way I want to try and get through to that final answer. Okay. So again, we ended up with that cosine as a final answer. But there are lots of ways that I could have gotten here. Turning everything into sines and cosines. Using sines and cosines and trigonometric functions. Now, I know this was a little bit more complicated. I get it. I'm all about keeping it simple. I would have done this. Okay? But some people aren't going to see this. Some people might see, oh, I can, manipulate it like this. All right? Okay. So let's do it again. Let's move on. I want to come back to this one. I'm going to save this for last. Okay, but normally in class, I would talk about this right now. Okay? But I'm going to save this one for last. So we're going to come back to that. All right, so here, again, it's another simplify. Can you please simplify this down? Either into a constant, a single trig function, or a power of a trig function. Again, I can replace all of these words up here, this entire sentence, with simplify. Go ahead, pause the video, give it a shot. Okay. So here, again, there's nothing wrong with turning this into nothing but sines and cosines. So we know that secant is really just 1 over cosine x. And cosine stays. But remember, this is like multiplying two fractions. Okay, what number is cosine over? It's over the number 1. And what's going to happen? The cosines cancel each other out. What am I left with? 1 over 1, which is the answer of 1. See, not that bad. This is what I was talking about. This is just a constant answer because these two, they're reciprocals of each other. And whenever you multiply reciprocals, you get the answer of 1. Okay? Another way so I turned everything into sines and cosines here. Another way, I could have turned cosine into secant, because cosine is 1 over secant, and I would have gotten the same answer. Lots of ways to approach this problem. Some people are going to see sines and cosines working. That's what I see. But some people will say, oh, I know that cosine is really 1 over secant, and they'll work it from that. Lots of ways to do this. Pause the video, give this one a shot. Okay. So in here, again, lots of ways that you can get through this, okay? Probably the easiest thing I think about for this one is let's turn this into sines and cosines, okay? Let's work with it like that and see what happens. So again, in the end, really with everything that it's saying, we should narrow this down to one trig function that's either itself or at a power, or it's going to be a number, okay? So let's change everything to sines and cosines. So secant is 1 over cosine. Tangent is sine x over cosine x. Cosecant is 1 over sine x. So I know that it looks like I made things more complicated, but I promise you it's not. It's just a lot of fraction work. Like I said, a lot of algebra skills are going to come into play here. And to kind of save, oops, I want to erase. Let's just grab this, move it over here, and work across. So first things first, I'm going to condense the numerator down. How do I multiply fractions? You just multiply straight across. So 1 times sine is sine x. Cosine times cosine, cosine squared x. Okay? So on the bottom, I still have 1 over sine x. And as we've talked about before, we do not divide fractions. We multiply by the reciprocal. So you're going to take sine x over cosine squared x times, because division becomes multiplication, flip sine x over 1. So again, when we multiply fractions, we multiply across the top and across the bottom. Sine times sine is sine squared x. Cosine squared times 1 is cosine squared x. Hey, wait a minute. I recognize this. What do I get when I have sine over cosine? Even though they're squared, it doesn't matter. Sine over cosine is tangent. So in the end, that giant thing just becomes tangent squared x. Because sine over cosine is tangent. And that's what they're looking for. That is a power of a trig function. I've got one trig function and it's got a power. That's A-OK. We could have done other work. There's nothing wrong with that. Okay? I mean, we could have changed, we could have done lots of manipulation to this. There's lots of ways. And it's all about just playing around with the identities that you know. And again, right here, I just changed everything to sines and cosines, and then everything else was algebra skills until the end when I used an identity. Okay? That's all that I used on here. Again, if you're having trouble with these, that's normal. So if you're getting stuck on these, that happens. That's normal. Okay? Because you haven't really done a lot of this stuff. But just know that you just need to keep practicing and practicing and practicing, because a part of every section that we do in here in chapter 10, there are some verifying that is going to happen that you need to know. And when it comes to quizzes and tests, please rest assured that we're going to make sure that whatever we're giving you, it's pretty straightforward. Okay? So you're not going to be too stressed out. I promise you. All right. So go ahead, pause the video, give this one a shot. All right. So you can take and you can turn these into sines and cosines and go through it from there. There is nothing wrong with that. It works just fine. Okay? But there's a faster way. But most of you are going to do the sines and the cosines. So I'm going to show you sines and cosines, and then we'll go from there. Okay? So we know that secant squared is really just 1 over cosine squared x. And then we're subtracting. Tangent squared, as sines and cosines, is sine squared x over cosine squared x. Hey, wait a minute. Cosine squared, my fractions have a common denominator. Cool. So let's put them together. Let's combine these two fractions. So we know that our denominator is cosine squared x. Our numerator will be 1 minus sine squared x. But wait a minute. We've seen 1 minus sine squared x before. That was like after we did the negative number identities, that was the first problem I threw at you. We know that 1 minus sine squared is equal to cosine squared x. That's a Pythagorean identity. All over cosine squared x. Hey, what's cosine squared x divided by cosine squared x? 1. There you go. Or the faster way, this is a Pythagorean identity. We have an identity that says tangent squared, so let me show you another way. Tangent squared x plus 1 equals secant squared x. Get tangent and secant all on the same side. That's what this says. Okay? So if I subtract tangent squared x minus tangent squared x, you find out that 1 is equal to secant squared x minus tangent squared x. Oh, look. This matches that. So I can replace it with the answer of 1. You could use Pythagorean identities on this one. You didn't have to use sines and cosines at all. Again, that's why I love this. You have these rules. You have these properties that you can use. And it's like a game. Sometimes you take the long route to win the game. Sometimes you're just cutthroat and you go right to the answer. You're like, boom! Checkmate. All right, so I showed you 2 different ways to do that guy. And there you go. Let's do another one. Pause and give this a shot. Okay, so, and here, again, constant single trig function, power of a trig function. So notice we got sines and cosines over here. We got sine over here. We got cosecant. Maybe this would be, a good idea to turn it all into sines and cosines. I mean, really all we would have to do is fix this. Okay? So let's do that. I forgot what I was going to do. Oh, yeah. I'm going to change up my marker sign. So I'm going to keep sine squared x, cosine squared x. Now, yeah, I know some of you, you're going to see that, oh, this is tangent. Okay? And let me talk about that real quick. Actually, before I do this, let me talk about that real quick. Some of you automatically are going to see sine over cosine. You're going to be like, okay, tangent squared x plus cosecant x sine x. And now you're like, okay, so I've got this. Now what? Because I've got three functions now. How do I deal with this? Well, so you go back through, maybe you see some things and you're like, oh, well, I know that tangent squared is the same thing as secant squared x minus 1 plus cosecant x sine x. And now you're like, okay, now what? So you can see how I was talking about, sometimes you're going to see things and you're going to want to do certain things, and it's going to take you down a path where it's getting messier. This thing's getting larger, not smaller. Okay? So maybe it wasn't wise for us to change this into tangent squared x. Okay? And then use a Pythagorean identity to change it to this. Okay? That's all I did to get from tangent squared x to secant squared minus 1. I used that identity that we were talking about right here. I just moved the 1 over. So you subtract 1 and you get tangent squared equals secant squared minus 1. So I'm just using Pythagorean identity. See, again, this is taking us down a road that we don't want to go. Let's change everything to sines and cosines. Since a majority of this is already in sines and cosines. Go figure. Leave it. So we just have to change the cosecant. Okay. Easy peasy, lemon squeezy. Plus cosecant is 1 over sine x. Sine x. Okay. Now we're kind of getting somewhere, right? Because these are just two fractions that are being multiplied. Remember that the sine is over 1. So what's going to happen over here? Well, everybody cancels out, and you're left with the number 1. Okay. And cosine squared x. Now, you're like, okay, so this is a fraction over here. Remember, 1 is over 1. So we can go and we can get a common denominator between these two and then add the fractions. So from here, we can just deal with fraction work. So how do I turn this with a common denominator of cosine squared x? Because that will be the common denominator. So what do I have to multiply this by? Yeah, I got to multiply this by cosine squared x. Cosine squared x. So over here, I get cosine squared x on top. And again, that's still the same answer as 1. This is kind of like the idea of multiplying the top and bottom, the numerators, by 1. Because cosine squared over cosine squared is still the number 1. Look, cosine divided by cosine squared divided by cosine squared is 1. Over here, since these denominators matched already, there's no need to change things around. So what we have then is this. Sine squared x plus cosine squared x, because these two don't get together. They're not like terms. And on the bottom, you've got cosine squared x. And now you're looking at that numerator like, that looks familiar. Yeah, it's because it is. Sine squared plus cosine squared is 1. So we can use that Pythagorean identity to change the numerator. 1 over cosine squared x. Now notice we have only one trig function. So this is a possible answer, but generally they don't like your trig functions to be in the denominator, just so you know. But we know what 1 over cosine is. So we can call this guy secant squared x. And that's the answer that they're actually looking for. Okay? So again, kind of changing the sines and cosines in the beginning kind of helped us out. Okay? Now, let me show you something else. Maybe you saw this, maybe you didn't. Right here at this part, okay, the sine squared x and the cosine squared x, we had this written out. That's what we had right there. And then plus 1. Maybe some of you are like, oh, wait a minute, I see something here. Sine over cosine, kind of like what we did earlier, we could have called this guy, and let me change this. Let's change it up. So after we did this over here, and we found that, oh, that's really just 1, maybe you're like, okay, what about this, Mr. Armstrong? Sine squared over cosine squared, that's tangent squared x plus 1. And I've seen that before. Look, tangent squared plus 1. Oh, secant squared. Boom, done. So there was a faster way to do it. If you saw that, again, some people will see that. Some people will just stick with the sines and cosines all day and get through it. Again, there's a time and place for everything. Sines and cosines don't always work out the best for us. Okay? Sometimes they don't always work out the best for us. But sometimes they do. Sometimes it's a little bit longer. Sometimes, if you know identities, then we can work that out. All right. So again, I want to show you that sometimes there's lots of, well, and I don't want to show you, and it's not sometimes, but some of these, they have lots of ways to get through them. Again, it's going to be about what you see, what you want to try and apply. Sometimes like when we began this problem, it took us down a road that it looked more messy than what it was. And then, when we went back and tried some other things, we were like, oh, now I can do this, or now I can change this out and put this in there, things like that. Okay. Again, I don't have a surefire process. Do this, then do this, then do this. All I can tell you are these are the rules. Try to win the game. Okay. All right. So we're getting there. We're almost done. Got a couple more, and then I'm going to go back to that one weird problem, number 6, and talk to you about what it is. So here, this is true verifying. We want to make this side look like that side. Okay? So here, this side looks like the more complicated side. Take this and see if you can turn it into that one. Or if you think this is the more complicated side, take this one and turn it into that guy. It doesn't really matter. Your call. Okay? So you've got the steps. You know what to do. Pretend like you're given one of these sides. Try to get the other answer out of it. And go. Okay. So things you can do. Try turning this into sines and cosines. Maybe that'll help. Or maybe it would help if you turn this, these are two fractions. Let's put them together. Okay. Maybe that will help. So let's put them together as fractions. Because remember, this guy is over the number 1. So the common denominator between these two is going to be cosecant. And the reason, trying to put them together as fractions, it kind of makes sense because over here, this is one fraction where cosecant is the denominator. So why would I want to change the sines and cosines when I already have cosecant as a denominator here? Why not? So, and the common denominator between the two fractions is going to be cosecant. So even better. So I know that I will end with cosecant in the bottom. We just got to see what happens in the top. Okay. So these two already match, so this numerator will still be 1. Now over here, I need to turn 1 into cosecant. So what do I got to multiply top and bottom by? Cosecant. You're so good. You guys are so smart. Multiply top and bottom by cosecant, which again is like multiplying by 1. So what's cosecant times cosecant? Cosecant squared. Oh, man, look at you guys. You're so smart. So there we go. And when we put these two fractions together, you get cosecant squared x minus 1. Hey, we have something that kind of looks like that. You have a Pythagorean identity that says 1 plus cotangent squared equals cosecant squared. If I just subtract the 1 and move it over here, oh my gosh, cotangent squared is equal to cosecant squared minus 1. It matches. So I can just take and replace cotangent squared x all over cosecant x. Now, because this is a verify, what's going to happen in your homework is there's going to be a multiple choice options down below this. And in the multiple choice options, it will show the work that we just did right here. Okay? So see, we got to that answer. It is now verified. Okay? So you would be looking for a multiple choice answer that, has putting fractions together. Okay? Or another way to do this, we could have turned this all into sines and cosines. So cosecant is 1 over sine. Over here, we know that 1 over cosecant is sine. Okay? And then again, you're just going to put fractions together. Okay? So what you have here, you'll be getting sine x minus, again, sine x. Okay? Is anybody squared up here? I'm missing. Nope. That's right. So we're going to multiply this guy by sine x over sine x. Okay? So we'll have 1 on this one because the denominators are the same. And over here, you'll have sine squared x over sine x. When you put this together, you got 1 minus sine squared x all over sine x. Hey, but wait, we know what this is. Okay? We know that guy. 1 minus sine squared is cosine squared x. And down below, I have sine x. I really do feel like I'm missing something here. That's weird. That is 1 over sine minus sine. Okay. So what is cosine over sine? Okay, because we can separate this out because this is like 2 fractions. Again, there's lots of algebra to this. So I can separate this into 2 fractions. Cosine x over sine times cosine x, because there are 2 cosines on top. So what is cosine over sine? That's cotangent. Another thing that we can do with cosine is we can make it 1 over secant. Wow, I'm just making this totally complicated. But some of you are going to try this. I feel like I'm missing something now. And that's still the same. So there's the cotangent, but this came out the secant. Let me go back and double check my work, make sure. So that's 1 over sine. This becomes sine. So weird, this should have worked out. Sine squared. Sine down there. And so that's 1 minus sine squared all over sine. And 1 minus sine squared is cosine, right? Yeah. And if I separate these, yeah, because this is all over 1. So weird. So what happened was, okay, I know what happened. So this is, this is one of those tricky things where, I've got to match this side over to the other one. So what you can do is, and this is some sneaky math. Yeah, this is why I probably wouldn't have done, turn everything into sines and cosines. They're going to show you the stuff in purple. But, I want to show you some things that you can do. Okay. So this is why, again, this is why I liked it right there. It just challenged me. It's like, so right here, I need to do some fixing. So in the end, so I'm keeping my end result in mind. Okay. Remember, we have a little thing that says, keep this in mind, the side that you're not manipulating. So in the end, what I need is I need to turn this into a cosine squared. Well, I need to get a cotangent squared out of this. And right now I have cotangent. And over here, I need this to become cosecant. So here's how this is going to work. Again, remember, I can multiply by 1 all I want. So this is sneaky, but this is what I'm going to do. I'm going to multiply this, and then I'll show you how I separate this out. So we're going to separate this into 2 fractions, but before I do that, I need to multiply by cosine, yeah. No, sorry. I need to multiply the top and bottom by sine squared x. I know this seems weird, but there's a method to my madness. So what that gives me is cosine squared x, sine squared x. I have to force this in. You'll see why here in a second. And then the bottom, I have sine cubed x. Now, if I take and I separate this, this is what it's going to look like. Okay? I'm going to move and create cosine squared x over sine squared x. Okay? That right there cotangent squared x. So I've used all the cosines, and I've used two of these. So that means the second fraction is sine squared x over sine x. When all is said and done, that reduces down to sine x. And what is sine x? It's the same thing as 1 over cosecant x. And when I put these back together, cotangent squared x over cosecant x. That right there, you're not expected to be able to do that. They're going to go with the obvious route. They're hoping that you can see this information and that you keep it together with the cosecant. But this is what happens when you want to change everything to sines and cosines. You notice that I hit a little bit of a roadblock down here, and I had to think about it for a moment. And this is one of those moments where I did what I was talking about, that tip 6. This is multiplying by 1 to make what I want happen. Sometimes you have to multiply by that 1 there. Okay? I know I probably just confused you over here. So if that's confusing, ignore that. Focus in on what the purple was. But there's two different ways to verify this. That's what I like about it. So, right over here, the stuff in the green, I had to use a bit of ingenuity and, thinking about what I wanted in the end in order to get there. But it is possible to turn this all into sines and cosines and get it over into this. Okay? Lots of ways to do it. All right. So let's not do that again. So let's just keep it plain and simple. So take the complicated side, which is this guy over here, get it to look like the other side, and go. Okay. So here, how over here we took these, like this multiplication, and we turned it into two fractions being multiplied. Okay? Because there is multiplication going on between these two up there, and I can separate them out into two fractions. You can do the same thing with addition. Okay? We can take this, and because there's subtraction here, that means that there are two fractions being subtracted. We've got cosine squared x all over sine x, cosine x, being subtracted from sine squared x, which is all over sine x, cosine x. Right there. There you go. See, we separated the two fractions. Sometimes it helps to separate your fractions. And then what's going to happen? Well, we know that this cosine will cancel out with one of the cosines up above because there were two. This sine will cancel out with one of the sines up above because there were two. So what do we have left there? You have cosine x over sine x minus, over here you have sine x over cosine x. Oh! Cosine over sine is cotangent. Sine over cosine is tangent. So right there, you have verified it. And again, down below in the multiple choice, you'll be looking for work like that. Okay? And it will be there. See? Verified. Nothing crazy. No, we're not going any other way on this one. I'm not going to show you another way. Okay? So that would be the straightforward way. That's the way I would do it. All right? Try this one, and then we're going to go back to that one problem, and we're done with section 10.1. And go. Okay. So if you look at this, this one's going to be a lot of fraction work. So we've got two fractions here. Let's put them together. So in order to put these fractions together, we're going to need a common denominator. And hopefully that common denominator you knew was going to be 1 plus sine and 1 minus sine. That's going to be the common denominator between these two. Okay? 1 plus sine, 1 minus sine. Okay? This is just like adding and subtracting rational functions that you learned in intermediate and performed in college algebra. So here's my denominator. Here's what I need. So I'm missing 1 minus sine x. 1 minus sine x. Here's my denominator. Here's what I need. I'm missing 1 plus sine x. 1 plus sine x. Okay? So this new numerator, 1 times all of that, is just 1 minus sine x. Because again, it's like distributing through. There really is a parenthesis around this. And the same thing over here. We're going to distribute this 1 through. And you're going to get 1 plus sine x. Okay? Now that we have common denominator, we can put these together. 1 plus sine x. 1 minus sine x. Up here, be careful with the subtraction, because remember, subtracting this actually needs to transfer through. That subtraction sign changes all of the signs that are up here. So this now becomes a -1, and that becomes a minus sign. Okay? So this subtraction goes through there, and then will become a plus. All right, so keep that in mind when you're going through and combining like terms up here. So what's 1 plus a -1? 0. What's negative sign plus a negative sign? That's not a plus anymore. That becomes a negative or a minus. So that gives you -2 sine x, because a -1 and a -1 are -2, and the sine x is kind of like a variable. Okay? Oh, look, we already got that -2 forming there. Okay? Now, before we continue on, you need to go ahead and FOIL out the bottom. Because when you FOIL out the bottom, you'll get this. You'll get 1 minus sine squared x. Hey, we know what that is. 1 minus sine squared x. That's cosine squared x. And then in the end, all we do now is we work this as if there were lots of fractions being multiplied here. So we're going to take -2, and we're going to separate, wait a minute. Sorry, that's not squared up here. Ooh, almost messed that up. So we're going to take this as if there were 2 fractions being multiplied here. One of the fractions is going to be sine x over cosine x, because I have 2 cosines down here. The second fraction will be 1 over cosine x. Because again, see, if I put this all together, remember this -2 is over 1. Cosine times cosine is cosine squared. And then -2 times sine times 1 is -2 sine x. So it's still all the same thing. This is like 3 fractions being multiplied right here. But we know what sine over cosine is. That's tangent x. We know what 1 over cosine is. That's secant x with a -2 in front. And there it is, verified. Okay, -2 tangent x secant x. Voila! Okay, this takes practice. Hopefully you feel a little better. I'm not saying a lot, but a little better at this. You're starting to see some things. Okay, and what you can do. This is a lot of algebra skills being put to the test. A lot of manipulations, fractions, and rationals and stuff like that. So just be careful. Again, when it gets to these verifying questions, like these last 3 that we had, it's a multiple choice question where down below you're going to see some of the work that we performed, and you pick the one that has the correct work as it goes across. Okay. So let's go back to that one problem I skipped over, and let me talk to you about what's going on here. All right, so in your assignment, here's what it's doing. It says complete the following so that secant is expressed in terms of the given function. So for each of these, they want to know, what does secant x equal in terms of nothing but cosine? What does secant x equal in terms of nothing but tangents? And what does secant x equal in terms of nothing but cosecants? So this final answer for secant x here has to have nothing but the trig function cosine. This answer for secant x here has to be nothing but tangents. And this right here has to be nothing but cosecants. Okay? So let's work through this. Let's talk. Well, this first guy is pretty straightforward. Okay? Actually, these first two are pretty straightforward. Go ahead, pause the video, and see what does secant look like in terms of cosine. And see if you can figure out what secant looks like in terms of tangent. This last one we're going to talk about together. And go. Okay. Well, secant, remember, what's the reciprocal of secant? It's 1 over cosine. And that is the answer to this first question. Secant x is equal to 1 over cosine x. And this answer is in nothing but cosines. That's what they mean. Show me secant in terms of cosine. Show me secant in terms of tangent. Now this one, hopefully you went to your little Pythagorean identity, because you can see that there's a Pythagorean identity that says tangent squared x plus 1 equals secant squared x. All you have to do is get rid of the square. How do you get rid of something squared? You square root it. Okay? So secant here equals plus or minus. Remember, when you square root both sides, you put plus or minus in front of the radical. Some of you probably forgot that. But most of you probably came up with this for the answer. Square root of tangent squared x, and I forgot the n. Tangent, come on. Squared. Oh, not writing because it feels my other finger on the screen. Tangent squared x plus 1. Most of you probably came up with that, but you need the plus or minus in front of it. And there's the answer. Easy peasy. Now let's talk this one. Now, there are lots of things you're going to be trying on this one. When I do this in class, I usually have you guys go through and think this through for me. And you guys are the ones that come out with this. Okay? And most of the time what happens, it usually takes us about 3 tries. Because the first one that we go through, you try changing stuff into sines and cosines. And then hopefully you can get cosecant out of it. And it doesn't work. Okay? Then you try using the fact that we know that 1 plus cotangent squared equals cosecant squared. And try to get that in terms of sines and cosines. And it doesn't work. Okay, so I'm going to cut to the chase and I'm going to tell you exactly the one that you need to use. In order to get this one, secant in terms of cosecants, you need to use sine squared theta, or actually in our case, x. You need to use the sine squared plus cosine squared equal to 1. And the reason being, because what's the reciprocal of sine? 1 over cosecant squared. What's the reciprocal of cosine? 1 over secant squared. Now we've got cosecant and secant all in the same problem. Okay? So let's go down and let's talk about this, and then we'll come up here and write the final answer in that blank. So we know that sine squared x plus cosine squared x equals 1. That's my hint. And then from here, we know that sine squared is really the same as 1 over cosecant squared. We know that cosine squared is really 1 over secant squared x equal to 1. So all I did was change these for the reciprocals that I knew they were. Okay? Pause the video from here and see if you can get secant squared or secant x by itself. Now that I've kind of given you that hint. Go ahead, give it a shot. Okay. So here's what I did going through the rest of this. Again, this is going to be a lot of algebra and fraction work. First thing, because I need secant by itself, I went ahead and moved this to the other side. So how do I get rid of a positive 1 over cosecant squared x? I subtracted 1 over cosecant squared x minus 1 over cosecant squared x. And so now I have 1 over secant squared x equal to 1 minus 1 over cosecant squared x. And now I'm going to put my two fractions together because remember, this guy's over 1. Okay? So I need to have the same denominator. So 1 over secant squared x is equal to, the common denominator will be cosecant squared x. Cosecant squared x. So this numerator is still going to be 1. This numerator over here, well, I've got to multiply this by cosecant squared x on the bottom and multiply the top by cosecant squared x. So this gives me cosecant squared x on top. Putting like terms together, well, actually putting my fractions together, I should say, we now know that cosecant squared x is equal to cosecant squared, or secant, 1 over secant squared x is equal to cosecant squared x minus 1 all over cosecant squared x. So far, so good. See how we're still got all nothing but cosecants over here? Don't change this. We got to leave this, okay? Now, here's a cool fact. Did you know that if these two fractions are equal to each other, then it's, so, well, let me give you kind of the same idea. If I had 1 over 2 equal to 1 over x plus 2, that if I did this and flip them, I will still have the same answer. Okay? If you take the reciprocal of each one of these fractions, this proportion still holds true. Okay? When you figure out what x, it will be the same answer as if you figured out x right here. So I'm going to apply that proportionality logic now. So if 1 over secant squared x is equal to cosecant squared x minus 1 over cosecant squared x, then that means this is also true. Secant squared x is equal to cosecant squared x all over cosecant squared x minus 1. That is also true. If you want to put the 1 under that, that's fine. You can, but you don't have to. Now see how we're even closer to this answer of just secant. Okay? We're really close to this. All we have now is, how do I get rid of something squared? And we're going to square root it. Okay? So now you have secant x equal to plus or minus the square root of cosecant squared x all over cosecant squared minus 1. So now we know what secant is in terms of cosecants. But in our assignment, again, this is all multiple choice. For each one of these pieces, it's all multiple choice. You'll need to clean this up because there's reducing and you have some rationalizing to do. Because remember, we have a property of radicals that says if you have a fraction under the radical, you can separate them out. And you need to do that. We have this property. If you have a fraction under a radical, separate them and continue on. Because remember, long ago, we had some Joe Schmo that says, I don't like radicals in the denominator. And so because of that Joe Schmo, we have to rationalize. So let's take a look at what we got here. So we got plus or minus. We're going to separate into cosecant squared x on top. Square root of that, of course. And on the bottom, we had the square root of cosecant squared x minus 1. I should have had an x over here. He's there. So what does a square root do to a square? Well, it cancels it. So on top, we have cosecant x. Kind of a nice piece. On the bottom, though, this square root does not take care of that. That doesn't happen, so we still have the square root of cosecant squared x minus 1. And again, remember I just talked about Joe Schmo that says, I don't like this. So we have to rationalize. So let me grab this stuff right there. And let's move it down here. So remember rationalizing, we've been talking about it. You did some of it in chapter 9. But just to refresh your memory again, to rationalize, you multiply top and bottom by whatever radical's in the denominator. So my radical down there is cosecant squared x minus 1. And cosecant squared x minus 1. So we have plus or minus. Our numerator, we have cosecant x square root of cosecant squared x minus 1. All over. And when you take these two radicals and multiply them together, remember we talked about this as well too before. If you've had me for intermediate algebra or college algebra, if you take two radicals that are the same and multiply them together, they have to be the same, then all that happens is whatever's underneath pops out. So square root of cosecant squared x minus 1 times the square root of cosecant x or cosecant squared x minus 1 is cosecant squared x minus 1. The radical just cancels itself out. And that, my friends, is what they're looking for. Okay? Lots of algebra skills on this. Rationalizing, reducing radicals, a must. That's why I did this one with you, and that's why I talked about this one, because this guy can be a pain in the neck. So in the end, this is the answer that you would look for in the multiple choice. Plus or minus cosecant x square root of cosecant squared x minus 1. All of this over cosecant squared x minus 1. Okay? 10.1 is, it's all about practicing on how to simplify, rearrange, plug in identities, verify identities. That's what it's all about. It's like a puzzle. And some of the times they give you what to start with, and then this is where they want you to go. Okay? Sometimes they don't. And as I've talked to you about before, it's like a game. And these are the rules you have to play by. Some of these have multiple ways to get through them. Sometimes it's easy. Sometimes it's hard. Like when I did that the long way on this problem, when I made everything sines and cosines, that was just a mess. But sometimes that's the way people see it, the hard way. Other times, as I talked about in this problem, sometimes if you just think about those Pythagorean identities, they help speed things along really, really quick. And that, my friends, is section 10.1. Have fun.